Good evening everyone, my name is Luckey Kumari, one of your tuition mate, and today I am standing in front of you to give my presentation on chemical reactions and equation. So from the chapter titles itself, first we have to know that what are chemical reactions and then what are chemical equation. A reaction in which a new product is formed and has entirely different properties those from reactant is known as chemical reaction. For example, burning of a magnesium ribbon in the presence of oxygen gives us magnesium oxide. Here is a reminder to remember that here we observe two observations, that is, first it burns with a white dazzling flame, and second it produces a white powder which is magnesium oxide. Now we have to know 5 key points to observe that whether the chemical reaction has taken place or not. These are change in state, change in color, formation of precipitation, evolution of gas, and change in temperature. Moving further, chemical equations is just simply the representation of chemical reaction in terms of symbols and formulas. To make our chemical equation more informative, we can write the states of the elements in the reaction. And we can also write the nature of the reaction, whether it is endothermic or exothermic. Here the question arises, what are endothermic reaction and what are exothermic reaction? The reaction in which evolution of heat occurs is exothermic reaction, and the reaction in which heat is observed is called as endothermic reaction. Moving further, we have 5 types of chemical reaction. These are combination, decomposition, displacement, double displacement, and redox reaction. Combination reaction is the reaction in which 2 or more than 2 elements or compounds combine to form a new product. For example, CaO combines with H2O to produce CaOH whole twice. Quicklime combines with water to produce slaked lime. Moving further, we have to remember that combination reactions are generally exothermic in nature. Second, decomposition reaction is the reaction in which breakdown of molecules or compounds into 2 or more than 2 simpler substances. Decomposition reactions are generally endothermic in nature. These are further divided into 3 groups: thermal decomposition, photolytic decomposition, and electric decomposition. Photolytic decomposition is the breakdown of molecules in the presence of sunlight. Example, AgBr, which is silver bromide, into silver and bromine. Electric decomposition is the breakdown of molecules by supplying electricity. Example, electrolysis of water. And last, thermal decomposition is the breakdown of compounds by giving upon heat. Example, breakdown of CaCO3 upon giving heat into CaO and CO2. Limestone breakdowns into quicklime and carbon dioxide. Moving further is the displacement reaction, in which the highly reactive element displaces the less reactive element from its compound or solution. The most common example is Fe plus CuSO4 gives FeSO4 and Cu. In this reaction, Fe is more highly reactive than Cu, so it displaces Cu from its solution. Moving further is the double displacement reaction, in which exchange of ions takes place and form 2 new compounds. In displacement reaction, precipitation forms, so it is also called precipitation reaction. Last is the redox reaction, which is also called reduction and oxidation. Oxidation is just simply the gain of oxygen and loss of hydrogen. Its vice versa is reduction reaction, which is gain of hydrogen and loss of oxygen. The last topic is corrosion and rancidity. Corrosion is the slowly conversion of metals into undesirable ones in the exposure to air and moisture. Its basically example is rusting of iron. To prevent corrosion happens when a metal contains impurities in them, it has dent in the metals, and it is highly reactive. Last topic is rancidity. Rancidity is just the decomposition of fats and oils which make the food unpleasant in taste and produces an unpleasant smell. To prevent rancidity, we refrigerate the food, we do vacuum packing. In the packet food, nitrogen gas is filled so that the food doesn't become soggy. This was my presentation on chemical reactions equations. Thank you.